Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and welcome to this session on regression analysis. Regression analysis is a very powerful tool which serves two purposes. It helps predict the nature of relationship between variables. If we look around in our life, we find that there are a lot of things which are dependent upon other things. Take the structure of a building. The columns and beams, their specifications, their strengths are directly dependent upon the height of the building and the span between the columns. The concrete curing time is inversely dependent upon the ambient temperature. More the heat, less the curing time. For you, postgraduate scholars, or for that matter, any student, the grade is dependent upon the amount of time devoted to studies. The mileage of a car is dependent upon the size of its engine. Bigger the engine, less the mileage. So regression analysis helps study such relationships. But more importantly, as far as we are concerned, regression analysis helps us predict. The main deliverable of regression is a regression line. You can also call it the trend line or the line of best fit. This trend line projects into the future, and because it projects in the future, based on this trend line, we can make predictions. You would recall this particular diagram from earned value analysis. On this diagram, all these KPIs which are indicated in red circles are nothing but predictions. What are those predictions, or what were those predictions based on? These lines, these dotted lines. At that time, we called these dotted lines the trend lines. But now, in the context of regression analysis, you could call them the regression lines. Also, you had come across this concept of trend lines when discussing the burn down chart in controlling schedule. So trend lines or regression lines help us predict because they project into the future. Whether regression is used for this purpose, which is to establish relationships between two variables, or it is used for prediction, in either case, we need to assess the quality of data. We need to ask ourselves, does the data make any sense? And the answer to this question lies in what is referred to as the correlation coefficient. It tells us whether the data makes any sense or it doesn't. Let's look at this data, this particular aspect. Here I'm going to show you a series of graphs. On the x-axis is the independent variable. Independent variable is always on the x-axis. Let's say, for the sake of simplicity, these are just numbers representing something, some quantity. And on the vertical axis is the dependent variable. That means this value is dependent upon this value. Now let's take 5 cases. If you look at this data, we find that this data is perfectly linked to this data. It increases proportionally with this data. In fact, we can draw a very nice straight line through this data. This data has perfect relationship between the independent and dependent variable. If the independent variable increases by 2, dependent variable also doubles. This is represented by a correlation coefficient or Pearson's coefficient of 1 maximum. This is the strongest or the perfect relationship between an independent variable and its dependent variable. Look at this data. Well, this data is not as strongly linked as this data, but you can still find out that as the independent variable increases, so does the dependent variable. Clearly, this data is heading in this direction or trending in this direction, and therefore one can very conveniently draw a line through this data, the line of best fit. This data is not as strong as this data. We call it, it is strong enough, though it is not as strong as this one. So if this is the benchmark, then the correlation coefficient over here is slightly less than 1 at 0.93. Look at this data. Well, this data too is trending in this direction. One can make out that it is heading in this direction, meaning thereby that as the independent variable increases, so does the dependent variable. And again, we could draw a line through the data. But compared to this, it is not strong. We can say it is moderate. In fact, the Excel sheet has worked out the correlation coefficient to be 0.72. In the previous case, it was 0.93. Now look at this data. Here, the linkage or the strength between the independent and dependent variable is rather weak, but you can still see a glimpse of a trend that this data too is indeed heading in this direction. Although the relationship between this data, between independent data and the dependent data is very weak, it is heading in this direction. So we can still draw a trend line. Also, this trend line is indicative of a very weak relationship, which is represented by a low value of R, which is 0.47. And the fifth case, this data is like headless chickens. It has no direction at all, and we say it has no relationship, and therefore its correlation coefficient is 0. So as we go from left to right, the relationship is weakening, and so does the coefficient is reducing. I have adopted a slightly different color scheme. I think this makes more sense than what is in your notes. In fact, I'll send you a copy of this after I'm through with this recording. These were the cases of direct relationship. That means when independent data increased, so did the dependent data. But there may be cases where when the independent data increases, the dependent data reduces. When the size of the engine increases, the mileage reduces. When the temperatures, when the outside ambient temperatures increase, the curing time reduces. In that case, the data looks something like this, and the coefficients are represented negative, because that means the trend is downward. So this is the significance of the correlation coefficient or the Pearson's coefficient. Now, looking back at these two aspects, the scope of your course is restricted to the use of regression as a tool for prediction, not for this. So what we are going to do is, because we are going to predict, for which we require a regression line, and every regression line, being a line, has to have an equation. So we are going to find the equation of the regression line. Then we are also going to establish the strength or significance or the meaning of that data. Again, answering the question, does this data mean anything? For that, we will have to establish the correlation coefficient or the Pearson's coefficient. Data regression analysis is of many kinds, but the 5 basic kinds are shown in this diagram. You do not have this diagram, but I'll emailing you subsequently. Regression could be along a straight line, it could be along a polynomial relationship, inverse relationship, logarithmic relationship, or an exponential relationship. Because of the limited scope of this subject in your course, we are going to confine ourselves to the simplest possible regression, which is the linear regression. That being the case, let's look at the dynamics of a straight line. This is a typical straight line. What does this straight line tell us? Well, this straight line, for starters, cuts the vertical axis. By the way, this is called the Cartesian coordinate grid, comprising of x-axis and y-axis, and a line is supposed to be comprise of coordinates. First, or every point on the line has an address. The first point tells us the distance of that point left or right of the origin, and the second point tells us the distance of that point above and below the origin. So when we say 513, this point has an address or coordinates of 5 and 13. That means it is 5 units to the right of the origin, which is here, and 13 units above the origin. So for starters, we find that this line cuts the x-axis at P. This is the equation of this line, and this 3 is the same as this 3 over here. So the constant in our straight line equation is nothing but the intercept, or the distance from the origin on the y-axis at which the straight line cuts the y-axis. In accounting, this will also be referred to as the fixed costs. Then is this 2. This 2 represents the slope of the line. How inclined is this line to the x-axis? For instance, this line has double the slope of this line. This line too passes through 3. That means it too has a constant or an intercept of 3, but it is 1x. That means its slope is 1. Or the slope of this line is half of the slope of this line. In accounting, the slope is also referred to as the rate, like 10 rupees per unit of electricity, or 600 rupees per kg of something. That's the rate. So that is what the slope is, and this is represented by B, or this number against the independent variable. How is the slope worked out? But a very simple exercise. We take differential of any 2 points along the line. Let's take with these 2 points, 5, 13 and 1, 5. So the differential is nothing but a ratio of the difference in y coordinates. What are the y coordinates? 13 in this case, 5 in this case. So the difference is 8 divided by the difference in x coordinates, 5 minus 1, 4. So 8 divided by 4 is 2. Therefore, the slope of the line is 2. One caution over here, the sequence should be the same. For instance, when taking differential in the numerator, if we take this point first, then this point should figure first in the denominator also. If we do not ensure this, the sign of our slope would be opposite. If the slope is positive, our answer would be negative and vice versa. So this caution is given over here. So having armed ourselves with the dynamics of an equation, we are now in a position to tackle regression. This is a simple situation, regression situation. The amount of cement consumed on a multi-housing project is a function of the covered area of the house. So we have a dependent variable, which is the amount of cement, quantity of cement that is required, and the independent variable is the covered area of the house. Let's say this project manager has this data from the past. He has so far built 6 houses. The covered area of this house was 10,000 meters square, and it consumed 30 tons of cement, and so on and so forth. And we have to carry out regression analysis. What does that mean? That means we have to find out this equation, y is equal to a plus bx, where a is the intercept along the a-axis and b is the slope. And also we have to find out the correlation coefficient r, which will tell us how strong the data is. If we convert this data into a graph scatter plot, we have to plot the independent data along the y-axis. So this is, along the x-axis. So this is the covered area, which is the independent variable. 8 means 8,000 meters square. And this is the dependent variable, which is the quantity of cement in tons. Here is the scatter plot based on this. For instance, 5 was 19, so 5, go left, it is 19. And this is the line, regression line, which is passing through the data, the line of best fit or the trend line. And I take this opportunity to explain why regression analysis, being so good, carries the negative term regression, which means going back. Well, if you look at this line is now representative of this data. That means, to all intent and purpose, this data lies on this line. But that means this data is now reverting to this line, going back to this line. Call this line the Sirat-e Mustaqim, and let's say these data points were stray points, Gumrah points. So what they are doing is they're getting back to Sirat-e Mustaqim. So that is why regression analysis is called regression analysis, that the data is regressing to one line. We have to find the equation a plus bx. How do we do that? If you consult literature online or read books or go to YouTube, there are numerous ways which they preach. There are ways in which you calculate in up to 12 columns. However, what I'm going to share with you is the simplest possible approach to regression analysis, which involves only 5 columns. 2 columns you already have over here, and another 3 columns are added for calculations. As simple as that. Let's see how we do it. This is the original data, the same data, this data here. Since there are 6 data sets, so n, which represents the number of data sets, is 6. We add 3 columns. The first column is just the product of the independent and the dependent variables. So 10 times 30 is 300, and so on and so forth. In the next 2 columns, we simply take the square of the independent variable and the dependent variable. So column number 4, we take the square of the independent variable. 10 squared is 100, and we continue. And in the next column, we square the dependent variable. 30 squared is 900, and so on and so forth. Excuse me. Next, we add them up. So this column adds to 56, and so on and so forth. And in statistics, summation is always represented by capital sigma. Now we have to look at 3 formulas for R, A, and B. The formula for R is, or it looks a little complicated, although it is not. Here it is. N is nothing but 6. There's 6 over here. Sigma xy is this figure over here. Sigma x is this. Sigma y is this. And again, sigma x squared is this. And sigma x whole square means square of this. Please remember the difference between the two. This is sigma of x squared, and this is this. Whereas sigma x whole square means this figure 56, sigma x has to be squared. So there is a subtle, there's a thin line between the two, but you have to appreciate the quantities are hugely different. Sigma x square is 594, sigma x is 56, so you have to be very careful here. So just plug in the values as shown. N is 6, sigma xy from here is 1851, so on and so forth, and we get to an answer of 0.95, which signifies that this data makes a lot of sense. It is a very strong data, or in this data of the covered area of the project and the quantity of cement required has a very strong relationship. Similarly, for A, this is the formula, and for B, this is the formula, and these are the answers. A word about units. Please remember that this coefficient, regression coefficient, is just an indicator of the strength of the data or the strength of relationship, just like an index. So it has no units. A, if you recall, A was the intercept on y-axis or the dependent variable. And what are the units of dependent variable? Tons. So we write here ton. B was nothing but the rate. And rate, how did we work out on that previous slide? We took the differential of y coordinates first in the numerator and the differential of x coordinates in the denominator. X coordinates means, y coordinates means, which were in the numerator, the dependent variable, so tons in the numerator, meter square in the denominator, so the units are tons per meter square. Based on this, this is our equation. Y is equal to A is this, plus Bx, B is 2.27. Please also notice that I have a color scheme over here. This is to tell you that these expressions are common. For example, this expression which appears in R also appears in B. This blue expression which appears in R also appears both in A as well as in B. And the black expression over here appears only in A again. Now, this is particularly useful if you are using the store mode of your calculator. All you have to do is calculate red once only, and it will be usable once again. Calculate blue once only, and it will be applicable to A and B as well. Calculate the black once only, and this will also be used in A. So those of you who would use the stored function of your calculator, this would be particularly useful for them. Now, from the point of view of exam, how will you do it? In real life, regression is done on a spreadsheet. Spreadsheet has formulas or it has other features, and it is a piece of cake to do it on a spreadsheet. Unfortunately, students and scholars are not permitted spreadsheets in the exam, and the best that they can hope for is a scientific calculator or an ordinary calculator. You could do this manually, but it will take a long time. It will easily take half an hour to 45 minutes. So some sort of calculator support is required. Let's take the basic use of calculator first. So what I'm going to do now is take this data, the column data, to the next slide, and try to give you a few tips on the most difficult formula, which is for this regression coefficient. Here we are. So this is the data, the column data summation, and this is the formula for regression. The most basic calculator that you need to have to be able to solve this question is which has these four functions: the square root, the square of the number, the opening bracket, and the closing bracket. Why square root? Because this is square root. Why square? Because this is square. Why opening bracket? Because those brackets are required inside the square root as well as on the top. Let me show you how. This is the first method. If you enter this data in any other way than what I'm going to suggest to you, the chances of making a mistake are very high. So you should be entering data like this: opening bracket, this one, then n. N is 6, so 6. Then is xy, so multiplied by 1851. Minus, then sigma x and sigma y. Sigma x is 56, sigma y is 181. It is a simple product, so that is over here. Close the bracket. And many of you would forget to do this and make a mess of your solution. Please close this bracket. Then divide. This line becomes division sign over here, and then square root. While starting, writing under the square root, please enter two opening brackets. One bracket for this expression here, the other for taking this whole expression. As you know, this whole expression is under the square root. So to put the whole expression under this square root, you have to have another set of brackets. So n sigma x squared, 6 multiplied by 594, which is sigma x squared, and then 56 sigma x whole square. What is sigma x? 56. It's whole square, so you enter 56 and then press x squared. When you do that, a 2 in subscript form will appear above 56. So this is how you will enter data. Once you have entered the data for the independent variable in blue, close it. Then start new opening bracket for entering the data for the dependent variable. Once you have entered 181, press the square this again, and you will get a 2 in the superscript. Close the data, the pink with pink bracket, which is for the dependent variable, and then the black bracket for the entire expression. And this is how, inshallah, you will get the value of R correct. You need to give the values to the correct to 2 decimal places. So the catch here is these 2 brackets. If you remove one of them, your solution will be spoiled. Or what you can do is do it this way. If you look at this formula, there are 2 expressions in the denominator and both are dividing this. So sometimes it is easier that if you split the denominator into 2, like here. This is the same, but here you do not bother about 2 opening brackets. Just put the independent variable data first, expression first. Then after closing it, second division sign and put the dependent variable again under the square. And you will inshallah get the same answer again. Also, the cursor on your particular calculator may behave in a very peculiar way. Particularly if you have to make a correction in data entry, then every calculator may have its own way of corrections. Again, you can consult with me in case you have a problem. Now comes the more interesting bit, using the scientific mode of the scientific calculators. Scientific calculators, broadly speaking, fall into 2 categories, the MS series and the ES series. This is a calculator from the MS series. This is a typical calculator from the ES series. The MS series calculators are optimized for mathematical and statistical functions, and some literatures refer to M as mathematical. Whereas ES calculator is not just statistics, but a lot more, like complex numbers, quadratic equations. In fact, this calculator is merged into this calculator. It has far greater number of functions. It is more powerful. It is more user-friendly. As far as regression is concerned, both these calculators are equally good. And from the data which I have collected from you, some of you possess this series of calculators, the others possess this series of calculators. So I will go over the same problem from your notes on these calculators one by one. First of all, I'll take this calculator. So let me change the screen. New share. Let's take this calculator first. Okay, here we are. This is, as you can see, an MS series calculator. Whenever you deal with statistics on a scientific calculator, it is always a good practice to clear the calculator of all the previous data which may be residing in that calculator and has the potential of interfering with your data. Therefore, we always start with clearing the data. If you look at this calculator, this is where the clear is. By the way, all scientific calculators have more than one function. Buttons on all the scientific calculators have more than one function to perform. For example, over here it is sine, but on top is sine inverse and something else which is so small I cannot read. The primary function of that button is listed on top, and the other functions are listed above. The color code helps. For instance, this is yellow colored, so in order to access this function, you have to go through shift. That means press shift first, and then you will be entitled to use of sine inverse as indicated over here. And then pink would indicate that you may have to use alpha or some particular function or operation on the calculator like regression or standard deviation, etc. So when we look here, it is the clear is on this button. If we just press this button, it will not go to clear, it will go to mode. Why? Because the clear is in yellow. So for going to clear, we have to press shift first and then press clear. And once you do that, the screen will show what do you want to clear. This data on some, it says memory clearance over here, statistics clearance, more data clearance, or all data that you want to clear. It is always good to say, okay, clear everything. When you do that, the calculator is going to ask you, do you want to really reset all the previous data? Because there may be some data which you may need. And you answer on a calculator, you answer through the equality key. Once you do that, this 0 will disappear and a dotted line will appear at the bottom. This means your calculator is now clear of all previous data. आपका calculator बावूजू हो गया है, and therefore it is now ready for any statistical operation. So therefore now we get rid of the screen and we can perform any statistical operation we want. Okay, we want to do regression. So let's go to the mode. On some calculators, you may have to press mode once, while on others 2 times. We press this button as many times with a view to getting regression on the screen. There's no regression on the screen at the moment, so we press once again. When we press this mode button the second time, we get these 3 things. Obviously, we are interested in regression, so we press button 2. Button 2 for regression. When we do that, it gives you the types of regressions that can be performed. Do you want to do linear regression, logarithmic regression, or exponential regression? Our interest is linear regression, so let's press 1. And now the calculator is waiting for data input. What data is to be input? The independent variable data and the dependent variable data. So if you have your example in front of you, the first data was that if the area of the house was 10,000 meters square, this was the independent variable. We separate it from the dependent variable with a comma, which is here. Then it required 30 tons of cement. Having entered this data, please pause, look at the data on the piece of paper you have, make sure it is correctly entered. Because when you do the next step, this data will disappear and you will lose sight of it. You will not be able to revisit. So now is the time to verify that you have entered it correctly. If not, then you have to use this cursor key, the delete key, and the shift key in sync with each other, depending upon whether you want to insert data or replace data. Again, the dynamics differ from calculator to calculator. So again, if you have any difficulty, discuss with me, but before you hit the next button, make sure that the data has been entered correctly. If you are happy, the next thing to do is tell the calculator that this is the data. And if you see here, DT written, which means data. But because we are doing regression analysis, that is why it is in blue. That means go ahead and press the button. When we do that, we get n is equal to 1. The calculator is now telling you that you have entered the first data set. All we have to do now is enter the other data sets. Remember, we have to enter 6. So far, we have entered 1. Now, without disturbing the screen, enter the second data set. The independent variable in the second data set was 12, comma, and the dependent variable was 32. Let me check. Yes, it is 1232. Okay, m plus, and it tells me that second data set has been entered. Now the third data set. Third data set was independent 6, comma, dependent 25. Cross check, correct, m plus n is equal to 3. Fourth data set, independent 15, comma, dependent 46. And I have made a mistake. I missed comma. So let me use delete, put comma, and 46. The dependent variable, let me cross check 15, 46, correct. M3, 4 entered, 2 left. Fifth was independent 8, comma, dependent 29, 8, 29, correct, M4, and the last data set 5, 19, independent 5, comma, dependent 19, sorry, error 19, cross-checking 519, correct, M plus, all data entered. And in fact, our regression is done. So what we can do is now clear the screen with AC. Now we have to retrieve the data. The regression has been done. The calculator has done the regression and the data is lying somewhere and we have to retrieve it. This data is lying where it says sample variance or SVAR, sample variance. This is where the data lies. But as you can see, sample variance is in yellow. That means we have to approach this by first pressing Shift 2. Okay. So all the calculations, not just the regression calculations, the calculator has done other thing. It has found the mean, for instance, the average of the data and everything else. But we are interested in A, B, and R. We don't find it on the screen, but what we do find on the screen is this arrow. This arrow tells us that there's more data to the right, so we can use this cursor to go to the right. Different data, but still not our data, but arrow is there, so we are hopeful that it will be there. So we press it once more, and lo and behold, it is there. So if we want to find A, we press 1 and equal to B, 2 and equal to R, 3 and equal to. So let's find out R. Remember, its value was 0.95, correct to the 2 decimal places. So let's press 3. And please do not forget to press equal to. And when you do that, here we are, 0.95, correct to 2 decimal places. To retrieve A and B, we repeat the procedure. Shift 2, press cursor once, press cursor twice. We want to find A. The value of A, if you recall, was 9.01. Let's see if that is the case. So we press 1. Please do not forget equal to, and here we are 9.01. And we are left with B. So repeat, Shift, sample variance, 2 times here. B is 2. Remember, the value of B was 2.27. 2 equal to 2.27 correct to 2 decimal places. So this, ladies and gentlemen, is how we do regression on MS series of calculators. Let's now do it on the ES series of calculators, for which I'll have to bring in the new calculator, which is here, and here we are. Again, we have to clear the past data first. Where do you find the clear button on this? This is clear over here. Again, this is in, the clear is not here. Clear is here. This is in, well, call it brown. Therefore, we have to press the brown button first, which is shift. So we press shift, then clear button, and the calculator asks us, what do you want to clear? The setup, the memory, or everything? Let's say everything. 3 is everything. Then he asks you once again, are you sure? You say yes, and you say yes through this equality button. And if you are not sure, then of course this is cancellation. So we are sure that we want to clear, so we press equal. So everything has been now cleared from the memory of these calculators. What we do now next is clear the screen, and our calculator is now ready for any statistical operation. We go to mode, and a screen which will be very different from the MS series will appear. This screen will appear. This calculator is capable of all these things, and this arrow shows that there are 4 more functions below it, but we are not interested because we have found what we want over here. 3, statistics. Regression being a statistical tool, we want to do statistics. Where is statistics? At 3. So we press 3. Okay, once we press 3, we get all these statistical operations. What we are after is A plus BX, the linear regression. So we press 2 to get A plus BX. And the moment we do that, we get the 2 columns, one each for the independent and the dependent variable. So simply start entering the data. Now we have to first fill in the independent variables, and then opposite to them, the dependent variables. Again, the first one was 10. And in order to enter, we use the equal to button. The next was 12, equal to. Next was 6, equal to. Next was 15, equal to. 8, sorry, 15 hasn't gone in because I haven't pressed equal to, so that's gone. 5 was 8, equal to. This is a very useful help to you. It tells you the data set. So the last one was number 6 was 5, equal to. So we have entered the independent data. Now we use this cursor, move to the right into the dependent variable. Now, rather than use this button to go up, because there is no data after 6, it is better and quicker to use the lower arrow, and it will immediately take you to the first data point here. So the first one was 30, equal to. Next 32, next 25, equal to. Next 46, equal to, next 29 equal to, and last one was 19 and equal to. Compared to the MS series, the beauty about this is that you still have the data. Before you ask the calculator to do the regression analysis, you have the data for verification. So let's check whether we have entered the data correctly. If we haven't, we can use the delete button and the cursor button to go into that particular column and correct the data. Again, because we have no data below 6, it is better if you press the downward button and it will take you right on top. So the first one was 10 and 30, let me check, correct. The next was 12 and 32, correct. Next was 6 and 25, correct. Next was 15 and 46, correct. Next was 8 and 29, correct. And the final was 5 and 19, correct. So we have entered the data correctly. Now we can tell the calculator to calculate, to do the regression analysis. And for that, although it is not the appropriate key, we press this and our regression has been done. Now we have to retrieve the data, the value of A, B, and R. And where are the values? If you look closely here, above button it says statistics. So our data is over here. It is in brown, so we press the shift button first. Shift 1. This screen comes up and against 5 it says regression. So we press 5. And here we are, the values of A, B, and R. Let's press 1 for A. Remember, its value was 9.01. So 1, don't forget equal to, and here we are, 9.01. We repeat the exercise for B, shift 1, 5 for regression, 2 for B. Remember the value of B was 2.27. So 2 equal to 2.27. Finally, the value of R, shift statistics on 1, regression on 5, R is 3, equal to, and we should get 0.95, and here we are 0.95. So that is how we do regression on the scientific calculators. I strongly recommend that you do it on scientific calculators. Once you get to grips with your calculator, it is only a matter of at the most a minute to do regression analysis, vis-a-vis 15 to 20 minutes if you do it manually using a calculator, and 30 to 45 minutes if you do it purely manually. So with that, ladies and gentlemen, we come to the end of this session on regression, and with that we also come to the end of this subject of forecasting. This has been my first attempt at recording a video. I'm sure there would be lot of voids and weaknesses. Please do let me know so that I can improve upon the next video. On that note, I wish you well. Allah Hafiz, and see you next time.